Hello and welcome back to another AP3 video. And in today's video, we're going to do SAT math problems, but problem analysis. The question asks the following. The data on the coat color and the eye color for 48 million kittens available for adoption were collected and summarized in a table above. What is the fraction of the chocolate colored kittens has deep blue eyes? Well, we're given a lot of information, obviously. So there's a total of 48 kittens. And they all have different coat colors and eye colors. But what are they asking for? What do we want to look for in this example? Well, we're told that we want the fraction of chocolate colored kittens. What does that necessarily mean? We only want to focus on this line because they're only asking for the chocolate kittens and nothing else. But they're also asking, in that specific portion, how many kittens have deep blue eyes. And which is that number? It's 12. So all we have to do is realize that when it says what fraction of chocolate or what fraction of XYZ, it's just that portion that they're asking you for. And then you gotta look for the other thing that they're asking you for as well, which is the deep blue eyes. So it'll be 12. Oh, I don't know why it's in highlighter. So it'll be 12 over 16. Now, this is an easy question, but in this video, we're going to go over harder questions that show the same concept, but in a more complex structure. Okay, this question might be a little bit hard, so let's read the whole thing, process every single bit of information, and let's take our time on it. A school district is forming a committee to discuss the plans for the construction of a new high school. Of those invited to join the committee, 15% are parents of students, 45% are teachers from the current school, and 25% are school and district administrators, and the remaining 6 individuals are students. How many more teachers were invited to join the committee than school and district administrators? This is a lot of information, so let's digest every piece of it. So every single highlighted color is important information that's separate. So what are we given? People in the whole committee that were invited is the following. 15% of people were students. 50% of them were parent students. 45% of them were teachers from the current high school. 25% from the school and district administration. And then the remaining is just 6 individuals as students. So what do we do here? Well, let's add up all the percentages. So we have 15. There's everybody in the committee is everybody that's given. So we can conclude that 6 is also a percentage because everybody that's stated was in the committee. So if 15% are parents, if 45% are teachers, and 25% are school and district administrators, we can add the percentages. So you would do 15 plus 45 plus 25, and we get 85% as a total. So 85% is everything but the students. So what does that mean for the students? Because the students is 6 students, or like there's only 6 students in the actual meeting, and there's 85%, that basically means that the other 15% to make 100%, meaning that everybody in the committee, that means that the other 15% is the students, because if you add 15 plus 85, that equals 100, and that shows everybody else invited into the committee. So 16 students is 15%. 15% of people in the committee. In the meeting. Or committee, yeah, committee. So now what do we do? Well, we're given that 15%, the 6 is 50% of a number. The way to figure out that number is to do 6 divided by 15%, or 0.115. And if you plug that into a calculator, you do 6 divided by 0.15%, or 15%, you get 40. So this is the total number of people in the committee. And now we can figure out how many people are there in the teachers, which they're asking for, and the school and district administration. If 45% of people in the committee are teachers from the current high school, you do 45% times 40. So I'll do that in red, like I did and highlighted. So 40 multiplied by 0.45 equals 18. And then for the 25%, it's 10. So 25% times 40 equals 10. And they're asking what is the difference, or what is how many more teachers instead of school administrators. So yeah, administrators or district. And if you add, or if you do 18 minus 10, you're left with 8. So what does that mean? That there are 8 more teachers in the committee than school and district administrators. It is important to know that you gotta understand that 6 is part of the percentage, because out of everybody that was in the committee, they give you percentages of teachers, of students. Actually, they give you the percentage of students, the parents, students, teachers, and administrators. They don't give you students. And if you add all the percentages, you get 85%. So the other 15% to make the full committee, or to show everybody in the whole committee, is the 6 individuals that are students. Let's do a unit conversion question. An oak of a tree, a sample of an oak, has a density of 807 kilograms per cubic meter. The sample is in the shape of a cube, where the edges have a length of 0.9 meters. To the nearest whole number, what is the mass in kilograms of the sample? Well, let's rewrite it now. So we have 807 kilograms per cubic meter. That's right, m cubed. And we're given that each edge has a length of 0.9 meters. So to look for the volume of a cube, we gotta multiply each edge 3 times. So we do 0.9 cubed, and that gives us 0.729. And this is important because we're looking for the mass in kilograms only. We want the cubic meters to cancel out. So because the volume of a cube is 0.9 to the power cubic, or 0.729, that is the cubic meter of the shape of a cube, or the volume. So when we multiply 807 kilograms divided by our pure cubic meter, and we multiply that by 0.729 cubic meter, these terms cancel out, and we're just left with kilograms. So all we have now is 807 kilograms multiplied by 0.729, and the answer, if you plug into a calculator, because that's what's offered to your calculator, you get 588, and that is the answer. Remember, it's important to know the cubic meter happens here in the cube because the volume to look for a cube is just the edges. So let's say edges equals x cubed. In this case, the edges equals 0.9, so 0.9 cubic meters. I hope that helps. Okay, let's do a question that's median. Let's see the following. The box plots summarize the masses in kilograms of 2 groups of glaciers. Based on the box plots, which following statements must be true? Now, we're given 2 things. We're given group 1 and group 2 in the distribution of their mass. What can we assume? What can we conclude? Well, I'm gonna draw it over here, right? Kind of like the same diagram, but just like no points. So here's the end, here's the end. Let's say a rectangle here, and here's like the center. So this is the center. So anytime that you see 2 rectangles and there's a center, this is the median, like the middle number. What's good about these type of box plots, you cannot, I'm gonna do this thing, you cannot determine the mean. It is physically impossible because they don't give you how many numbers of 24 or 26 or 28. No, the only thing you can conclude is the median itself, and that is it. So let's see the following options. The mean mass of group 1 is greater than the mean mass of group 2. Again, we cannot determine the mean. So A is wrong and B is wrong because they're both talking about mean. Let's see the medians of group 1 and 2. We can see group 1's median lands on 25 and group 2 median lands on 24. So group 1 has a higher median than group 2. So let's see our C and D. The median mass of group 1 is greater than the median mass of group 2. That doesn't make sense. Let's see D to make sure that C is correct. The median group 1 is less than the median group 2. That is incorrect. So our answer is C. So now it's easy. So when they ask you about which of the statements is true, if 3 options talk about mean, you cannot determine that. Unless one of them say you cannot determine the mean, and they tell you like it's greater or less or equal to, all those options are wrong. You can only conclude what the median is in these type of questions. Before we start anything, let's go over what standard deviation is. So I'm just going to write SD for standard deviation. And it's basically the measurement showing, showing how much a set of data is spread out from its average value. So showing how much a set of data is spread out from the average value. Or mean. So because average value is just mean. So I'll just write in parentheses over here in red. So what does this mean? What can we conclude? What we can conclude is that when there's higher standard deviation, the information or the numbers are more spread out. But if the standard deviation is less, it's more compressed. So when it's higher, there's more dispersion. It's more spread out. But when it's lower, the data is more condensed, more close together. I hope that makes sense. But I want to explain that just for other questions. It's not really relevant to this question because you need to know what standard deviation is in order to figure out if it's equal, greater, or equal to, obviously. But for this question, you don't need to know the definition, but it's good to know what it is because a lot of questions will ask you about standard deviation and they probably won't give you a plot most of the time, so you got to understand the concept. So the question asks the following: which of the following statements must be true? Well, let's look at statement 2 since we're talking about standard deviation. The standard deviation of set A is equal to the standard deviation of set B. So what does that mean? That means that the distribution of data set A should be equal to data set B. So let's look at 13, which is like the middle number. We see that there's 3 and 13. There's 3 13s in A, but there's 1 13 in B. And we can see that the rest is the same, but the middle is not the same. So they have different standard deviations because if they're both equal, they should have the same amount of points on both and every single number on both dataset A and dataset B. So the second claim is false. So that just erases 2 and C. Let's see if 1 is true. The median dataset A is equal to the median of dataset B. The median is just the middle number of dataset A and dataset B. And both points have 17. So dataset A has 17 points, dataset B has 17 points. And if we count the middle, which it would be 9, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9. 13 is the median for dataset A. And if we count 9 on dataset B, 1, 2, 3, 4, 5, 6, 7, 8, 9, same thing. Median is also 13. Therefore, we can conclude that the median in dataset A is equal to the median in dataset B. So the answer is A. So standard deviation is important to note, but in this question, because they have different values in 13, it is not the same. Okay, let's do the last question for today. The frequency distribution above summarizes a data set which A is a positive integer, and we're going to talk about that because that's a really important information. How much greater is the mean of the data set than the median? Well, what does A equal? What can A possibly be? Well, we're given that A is a positive integer, and A can be a negative or a positive value that is not a decimal. So it could be -1, it could be 1, it could be 100, it could be even a million. Let me write that correctly. But it's any number that is negative or positive and that is not a fraction or decimal. I believe it could be 0. Let me fact check that really quickly. And it could be 0 too. Just want to make sure I'm giving you guys the right information. So because a can be any positive integer, let's say a equals 1. Makes our life easier. A equals 1. So they're asking us for the mean and the median. So what are we given? Remember, mean equals the average. So mean or average equals the frequency or the total value, the number of all values combined, divided by the total numbers used. So let's see for the mean. So we're given, if a equals 1, we can change the points to 1. 1 multiplied by 2 is 2. 1 multiplied by 3 is 3. 1 multiplied by 2 is 2, and then 1 again. So we can see we have 9 values. Because if we add all the a's, we're given that there's 9 a values. So we can rewrite it as average, or a equals 9. And now all we have to do is multiply the numbers together. So now that we know a equals 1, I'm just going to make that right here. A equals 1. So now all we have to do is do 1 multiplied by 1 equals 1. 2 multiplied by 2. I'm just getting the value numbers and the frequency numbers combined, which equals 4. 3 multiplied by 3 equals 9. And 4 multiplied by 2 equals 8. And 1 multiplied by 5 equals 5. If we combine the values, we get 5 plus 9 plus 13. So we would get 27. That is the value of all the numbers combined. So that would be 27. So 27 divided by 9 equals 3. So average, or the mean, equals 3. And that is our mean. For median, it's just the middle number, or 5. Because if I have 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, we see that 5, there's 4 on the left side and 4 on the right side. So in this case, the median would be where the value equals 3, and we can see that right here. So median equals 3. And they're asking us, what is the greater number mean? What is the greater number is the mean of data set than the median? They both equal the same, so we do 3 minus 3. That equals 0, so the answer is A.